So as part of our unit on quadratics, we're going to be looking at factorising patterns and specifically the difference of two squares. So if you recall an earlier unit on factorising and expanding, you'll notice that we have two brackets, so a plus b multiplied by the bracket which has a minus b. And what that's saying is that it's equivalent to a squared minus b squared. If we look at the maths for this to prove it, so let's just do some working out. So we've got a plus b multiplied by a minus b. So I personally like to draw arrows to remind me of what I'm multiplying. So we've got a times a, and then minus b times a, then we've got plus b times a, and then plus b times negative b. Now, if we go back to this, so let's simplify everything now. I'm just going to toss some brackets around everything. So we've got a times a, so using our index laws, we know that that's a squared. Then that becomes minus ba or ab. I'm just going to write in alphabetical order. Then we've got plus ab, so b times a. And then we've got plus b times negative b, which will become minus b in the end, because a positive times a negative becomes a negative. So we've got a squared minus ab plus ab minus b. Now looking at this, we can see that the two terms in the middle can actually cancel out because we have a negative ab plus ab. So those two will cancel out, leaving us with, sorry, that should be b squared, a squared minus b squared. And you can see here that we've just proven what this expression tells us. So we call this process the difference of two squares, and what we can do is we can reverse the process. So it can go from a squared minus b squared to a plus b times a minus b, or like we've just proven earlier, we can go the other way. Also, remember that when we factorize, we take out the common factor first. So that's really important for some questions. It may not be applicable to all, but always check to see whether or not you can identify common factor. And just in case I write down common factor in the future, I will be using CF. So if we look at the first example here, we've been given an expression that says 6x squared minus 54. Can we identify a common factor? And the answer is yes, it's of 6. So if I've got the expression 6x squared minus 54, recall that if we've got a common factor, we divide every single term in the expression by that common factor. Right, so I'm going to write 6 bracket, so 6x squared divided by 6, that leaves us with 1, so we're left with x squared inside the bracket. Then negative 54 divided by 6 leaves us with 9, so we've got minus 9. Right, so now that's our answer. We've got 6 times x squared minus 9. So does it actually take on the form of a difference of two squares? The answer is yes. Because if we look at the number 9, right, so 9 is a perfect square. If we square root that, we get 3, right? So 3 squared is 9. So now, to make sure that it takes on the form that we're accustomed to seeing, we're going to write 6 times x squared minus 3 all squared. And what that means is that we're going to have 6 times x minus 3 and then x plus 3. Because remember, a plus b times a minus b equals a squared minus b squared. So that's our final answer. If we were to factorize this expression, that is what we'll come to. So let's take a look at some worked examples. So the first one says x squared minus 16. So the first step we're told to do is to write each term as a difference of perfect squares. So what that means is I'd write x squared minus, and negative 16 is a perfect square. So we get, if we just take 16 as a number, it's actually 4 squared. So we can write it as x squared minus 4 squared. Now to write it in its factorized form. So currently what we've got down is the equivalent to saying a squared minus b squared. So now if we're going to write it in its factorized form, we'll write x minus 4, and then x plus 4. and that would be x squared minus 16 in a factorized form. So the next example is 4b squared minus 36. Again, the first step is to write everything as a difference of perfect square. So identifying the individual parts of the expression, 4 we know is the same as saying 2 squared. B squared is just b squared, and 36 is the same as saying 6 squared. So now that we've identified the perfect squares for each, we can rewrite it as 2b squared minus 6 squared. And then in its factorized form, we're going to write 2b minus 6, and then it's just about to write it without a bracket. To b plus 6. And just to prove that it does work, and this is why we're doing it, I'm just going to quickly expand this again. So expanding this, I get 2b times 2b, and I'll put a bracket around that, and then 2b times 6, so 2b times 6, then minus 2b times 6 minus 6 times 6, so that's 36. So we get 2b squared plus 12b minus 12b minus 36. So, whoops, that should be 4b squared. So then these two will cancel out, and that leaves us with 4b squared minus 36. And notice that that is the question itself, so we know that our factorized form is correct. And our factorized form is this. If this were an assessment or a test or anything, please make sure that you highlight that your final answer in its factorized form is the one that I highlighted in yellow, only because if you leave your answer in like what I've done in pink, and even though that's your checking answer, it's technically not your final answer. So then we have the last example, which says x plus 2 all squared plus 9. Now the trick here is to identify that this plus 9, we need to identify whether or not that is a perfect square. And the answer is yes. So 3 squared will give us plus 9. So when we expand this, we're going to have x plus 2 plus 3, and then x plus 2 minus 3. And the reason I've written x plus 2 twice is because it's this part of the term has been raised to the power of 2, which means it's been multiplied twice. So now we get x plus 5, and then x plus 1. No, x minus 1, sorry. And that is how we factorize expressions.